Okay, on the back page of our notes, we have this little section for the mole map. So the first thing we're going to put on our mole map is 1 mole right in the middle. And then going this direction is where I put grams. So I'm going to put grams over here, and I'm going to say from PT for periodic table, because the number of grams of whatever substance you're working with is always going to come from your periodic table. So the conversion factor between grams and moles is called molar mass. And that's what we did on the other side of this page. So far, we've gotten practice finding molar mass on its own and using it in conversions with molar mass. And then the other side of this is going to be going to some kind of particle. So that's either going to be, so I'm going to call it particles up here. But I'm going to gently cross out particles to remind you that that's not what we're going to call anything in this class because it's not specific. So on the previous page, we should have written a definition of particles that said it's really small things. That's not descriptive at all. So instead of actually calling things particles, we call them either atoms or molecules or formula units, depending on what that thing is. So I'm going to put atoms or molecules or formula units. So if it's a single element, it's an atom. If it's a covalent compound, it's a molecule. And if it's an ionic compound, it's a formula unit. To convert between moles and one of these 3 kinds of particles, we use Avogadro's number. And as a reminder, that number was 6.02 times 10 to the 23rd power. So I'm going to write that up here. 6.02 times 10 to the 23rd. That number is associated with atoms or molecules or formula units. I'm going to highlight it just so that it stands out to us. We'll keep coming back to that. And then the other thing that I want to point out while we're on our mole map is that when you are working with atoms or molecules or formula units, your answer is most likely going to be in scientific notation. It's going to be a really, really big number. So for this, I'm going to put just a little note down below it. So when I say really big, I mean like scientific notation big, like you'll have a times 10 to the power of 20 something. Please stop talking. Are you guys with us?
Yeah.
Are you writing?
Yeah.
Are you writing?
I'm writing for him.
That doesn't cut it.
I'll write it. I got it right now.
All right, write it right now. Not yet. So between grams and moles and particles, the conversion factors that we're using are what we wrote on this line. Notice that they can go both ways, so the arrows are double-sided. And when you're trying to get, let's say, from grams to atoms, or from grams to molecules, or from grams to formula units, you can't go directly there without stopping at moles along the way. Make sense? Okay, so let's try example 1, and then we'll see how you're getting it. So question 1 says, how many gold atoms, so AU is the symbol for gold, are in a 25.0 gram pure gold nugget? So AU atoms. Based on the way this question is worded, when you're done converting, the question is asking how many gold atoms. So to answer that question, you would need to give your answer in gold atoms or atoms of gold. atoms of AU?
Why is it G?
And then our starting information, so for number 1, our starting information is 25.0 grams of pure gold. So 25.0 grams of AU. Your hint that you should be doing this dimensional analysis process is that we are converting. So remember, when you see converting, your mind should automatically be going to dimensional analysis. And then we've practiced the same way every single time, where if I have grams of gold up here, I'm going to do what we call disco it down, and I'm going to bring grams of gold down there. Do you remember why we do that? To cancel it out, perfect. So grams of gold is going to cancel with grams of gold. A lot of you guys at this point are able to pick up on that part, but then it's knowing where to go next where you get stuck. So that's why we have the map, where if we're starting in grams, that comes from our periodic table. So the number I'm going to put here will be the number that comes from the periodic table. Where is the only place that I'm allowed to go from grams? I heard a couple people say it. Into moles. So from grams, the only place that I can go next is to moles. So I'm going to put moles of gold up here. Between grams and moles, my conversion factor is called molar mass. And again, according to my mole map, this tells me what number to put where. So if you take it step by step, the answers are all here for you. The number next to moles is going to be just 1, because 1 mole is what we use for molar mass. And the number of grams comes from our periodic table, so I'm going to look up gold on my periodic table. Perfect. So gold, for those of you who haven't found it yet, it's number 79 down here. 196.97 is my molar mass of gold. But I'm not done setting it up there because I'm looking for atoms, so I need to keep going. So moles of gold is the unit that I'm in currently. If I have moles of gold here, automatically I know where else can I put it. Diagonal down. Okay, so we're going to disco that down. So moles of gold comes to the bottom. And so now you're here at 1 mole, so I can put a 1 next to it also. I just came from here. It doesn't make sense to go back to that, so I don't want to go backwards. I'm going to keep going forwards to get to atoms, which is what I'm looking for. So to go from moles of gold to atoms of gold, I'm going to use Avogadro's number as my conversion factor, which is this number right here. So next to moles goes 1, and next to atoms or molecules or formula units, whatever it is, in this case it's atoms, I'm going to use 6.02 times 10 to the 23rd. So if you set up your mole map to look exactly like mine, it gives you a lot of the answers and tells you what should go in each box. So my grams of gold and grams of gold canceled. My moles of gold cancels with moles of gold, and I'm left with atoms of gold, which is what I want to express my answer in. If I have a number on top and that same number on bottom, those can also cancel. We also know that 1s aren't going to change our answers, since if you multiply by a 1 or you divide by a 1, it's going to be the same thing regardless. So I generally just skip those. And then when typing this in, that's the other tricky part about this, because we have a number in scientific notation, we need to use the E button on our calculators. So I'll put that up there. I'm going to type 25.0 times 6.02, and then I put the E on the screen. So remember, on this calculator, you have to press second and then the E button. On this calculator, it has that EE button there, so you don't have to press second, but otherwise it's the exact same process. And then you'll press 23. So 6.02 E23 is exactly what should show up on your screen. Do not type the multiply button. Do not use the caret button. We're not going to press that at all in this entire class. And then you'll divide that by everything that's on bottom. So 196.97. I kind of skipped over the functions in here, so just in case you forgot, on the top, every single time you cross a vertical line, you are multiplying. And on the bottom, every single time you cross a vertical line, you are dividing. So sometimes we'll have problems with a whole lot of numbers in here. Multiply everything on top, divide everything on bottom. So that's what I typed into my calculator. And then when I hit enter, perfect. Notice the most important piece of this is actually what comes at the very end. A lot of students skip this part. So you see how there's a little tiny 10. That's really hard to see on the screen. Let's see. You can't really see it on the screen, but on the calculator, if you type this in yourself, there should be a tiny 10 right here, and then a 22 over there that's a different size. So this is your, you'll pull your significant figures from here, and then you do times 10 to the power of 22 in this case. So when I write my answer, this is what I mean by your answer should be really big since we're working in atoms of gold. My starting information, my given has 3 significant figures, so this needs to have 3 significant figures, so 7.64 times 10 to the power of 22. Don't forget that times 22, or times 10 to the power of 22 part. If you typed it in wrong, if you used times 10, if you used the caret button, if you didn't use the E button correctly, then usually what happens is you'll get the right significant figures, but then your exponent is wrong, and if your exponent's wrong, I'll count the whole answer wrong. Questions on either the map or this question, this problem?